If you, like us, has spent the last couple of years playing with generative AI, chatbots, summarization tools, all the large language models, you probably feel like you've been right at the absolute cutting edge.
Oh, absolutely.
But based on the stack of sources we've been reviewing for you, those tools are already becoming the foundation, not the frontier.
It's an incredible pace of change. I mean, what we're seeing now is this fundamental structural shift happening in computational architecture.
Right.
We are moving past just using LLMs as these sort of conversational tools into a completely different era, the age of the autonomous AI agent.
And the sources frame this as, and this is a huge claim, the most significant paradigm shift in enterprise computing since the cloud.
Since cloud computing itself, yeah.
Yeah.
That's a bold statement, but it starts to make sense when you look at what these agents are actually designed to do.
It's no longer just about getting a better answer from a chatbot.
Exactly. It's about getting a task completed end to end.
So our mission in this deep dive is to guide you through all that complexity, what we're calling the advanced orchestration of autonomous systems. We really need to nail down those foundational definitions. What actually makes an agent an agent? Then we'll get into the architectural shifts that are driving this in 2026, and crucially, the mandatory safety and governance rules.
Right, because you need those for these proactive systems to even be allowed to operate.
Right.
Our goal here is really to give you the shortcut to understanding this next wave of automation before it completely changes your org chart.
Okay, so let's unpack this.
Right.
We have to start with the fundamental difference. What is it that distinguishes a modern AI agent from, the sophisticated LLMs we were all using a year or two ago?
The core difference is, well, it's summed up in one powerful word: agency.
Agency.
Traditional LLMs are reactive. They wait for a human prompt a command, and then they respond. An AI agent is proactive. It's given the ability to perceive its environment, formulate a multi-step strategy, and then execute actions toward a goal.
Without constant human oversight.
Often without it, yes. That's the key. So it's not just generating text, it's generating a goal, a strategy, a whole workflow. It's deciding what needs to happen next based on what the world is telling it.
And the key operational concept for that is something called reasoning in loops, right?
Precisely. An agent can evaluate its own results as it goes. If step 2 fails, say an API call returns an error, it doesn't just stop. It doesn't just say, I can't do that.
It adjusts.
It adjusts its plan, maybe tries a recovery strategy, and it keeps working until the ultimate objective is met. It's persistent. And that persistence is the game changer. It moves AI from being a clever information assistant to being, well, a digital worker.
A digital worker, and that's why we're seeing these dramatic forecasts.
It is. Gartner's predicting that by 2028, at least 15% of enterprise work decisions, and we're talking about real consequential decisions, not just scheduling a meeting, will be made autonomously by AI agents.
Wow. And that's up from
virtually zero in 2024. That statistic alone tells you the scale of the transition we're talking about.
15% of critical decisions made autonomously. I mean, that's massive. And to be frank, for a lot of people listening, that probably sounds a little terrifying, especially when you think about liability.
Of course.
Are the sources clear on how we manage that kind of power? Does operating in a loop mean we need a whole new way to think about governance?
Oh, absolutely. And that's why governance is woven through this entire discussion. The power of agency is only useful if it's predictable and, auditable. The sources really emphasize that this architectural shift must be paired with these mandatory action-level guardrails, which we'll get into.
So you can't have one without the other.
You can't. You cannot have autonomous decision-making without a system that dictates exactly where and when that's allowed to interface with, say, high-stakes financial or data systems. It's a non-negotiable prerequisite.
Okay, so let's track that evolution.
Yeah.
The sources we looked at describe 3 pretty clear phases in this evolution of intelligence interfaces.
Right.
Phase 1 was just tools, pre-2022. That was the era of fixed logic deterministic automation, RPA.
Right, robotic process automation. The value then was just simple efficiency in really repetitive, highly structured tasks. If the data changed even a little bit, the whole thing broke.
Then came phase 2, models. That's roughly 2022 to 2024. These are the conversational LLMs we all know.
And the primary value was information synthesis, summarizing, retrieving knowledge, generating text.
And now we're firmly in phase 3, agents, 2025, 2026. These systems are goal-oriented, they're adaptive, and they offer that huge value of true end-to-end task completion.
Right, and to understand how they do that, the sources break down the anatomy of agency into 4 critical pillars.
I really like the human body analogy they used here. It makes it all a lot more tangible. So the large language model itself, the LLM, is the brain.
It's the core reasoning engine, the semantic understanding.
And the planning module is basically the prefrontal cortex. This is the part that takes a huge goal, something vague like fix our supply chain issues, and breaks it down into hundreds of small, manageable, verifiable subtasks.
It's doing the scheduling, figuring out dependencies, all that flow control.
Then you have the tool-use interface. This is the hands.
This is how the agent gets out of the sandbox.
Right. It interacts with the real-world databases, CRMs, financial systems, all through standardized APIs.
Yeah.
It translates the brain's instructions into code that actually does something.
And that leaves the final and maybe the most vital piece, the memory system. This is the key to that persistence we talked about.
No.
Without a robust memory, every single interaction is a brand new, isolated conversation.
The agent never learns.
It never builds on its past experiences. So, if the agent successfully processed an invoice last Tuesday using a certain sequence of API calls, the memory system lets it recall that successful strategy and use it again this week.
It doesn't have to reinvent the wheel every time.
Exactly. You need that persistence across sessions. And this memory system, it's usually housed in what's called a vector database. We see names like ZEP or Quadrant pop up a lot in the source material. And this isn't just a normal database. It's designed to hold huge amounts of your company's domain knowledge in a way that the LLM, the brain, can find meaningfully related information, not just keywords.
So it provides historical awareness.
Yeah.
Which brings us back to that planning challenge. If I tell an agent, analyze our market competitors, that's incredibly vague.
Super vague.
How does that planning module, that prefrontal cortex, actually break that down into concrete steps?
Okay, so let's take your example. A simple LLM might just write a summary of who it thinks your competitors are. An agent has to execute a measurable plan.
Right.
So it would see the vagueness and start a step-by-step process. Something like, step 1, I need to define the competitor set. I'll use our internal sales data for that. Step 2. Now I'll query our internal vector database for recent press releases from competitor A. Step 3. At the same time, I'll access a third-party financial API for competitor B's Q3 earnings report. And then step 4, I'll schedule a sub-agent task to synthesize all those findings into a final document. The planning module sees that step 4 can't start until steps 2 and 3 are done. That's the difference. It's orchestrating work across different systems, not just writing an opinion.
Once we get the idea of a single agent, the sources immediately pivot to advanced design. They make it clear that the future isn't some monolithic agent, one giant AI trying to do everything.
No, not at all.
It's orchestrated teams of specialized agents, what they call multi-agent systems, or MAS.
It's an architectural evolution that, it's a parallel to the shift from monolithic software to microservices we saw a decade ago. For any complex cross-functional project like, say, onboarding a new enterprise customer, these MAS environments are just way more agile.
Because you get modularity and error isolation. So if your billing agent has an issue with the ERP system,
your security agent and your compliance agent just keep on working without interruption.
Exactly. Now, the trade-off is coordination overhead. You need systems to manage how they all talk to each other.
Yeah.
But the benefits in robustness and flexibility, they just overwhelmingly outweigh that.
And speaking of complexity, a really critical design pattern has emerged for financial optimization. The sources highlighted this planner-executor pattern. Can you walk us through the economics of that?
Yeah, this is a huge cost-saving mechanism. The biggest, most advanced LLMs, the frontier models, are extremely expensive to run.
In tokens and latency, right?
Exactly. So in the planner-executor model, you separate the strategy from the execution. The expensive, powerful model acts only as the planner. It defines the complex multi-step strategy.
It just draws the map.
Then, a much cheaper, often smaller, or even an open-source model acts as the executor. It handles the individual low-stakes steps.
Like running a simple database query or something. Or formatting a document, yeah. The expensive brain is only used for high-value strategic thinking, while cheaper workers drive the car. This just dramatically optimizes your token usage, which leads to big cuts in operational costs.
That makes perfect business sense. Okay, let's dive back into the cognitive logic. For these agents to actually execute the plan, they need a way to think in a structured way. You mentioned the React framework earlier. Why is that reasoning plus acting so important?
React is how we get transparency and, critically, audibility. When an agent uses React, it's forced to generate a clear, verbal rationale, a thought step, before it takes its next action.
So it thinks out loud.
It literally thinks out loud. Instead of jumping from prompt to action, it says, okay, my goal is X. To get X, I should first verify Y, therefore I am now calling API Z. And this means if the action fails, we can go back and audit the agent's reasoning process and see exactly where the logic went wrong.
That kind of transparency feels like a must-have for any high-risk application. But once the system is live, how do these things actually get smarter? The sources had a lot on self-correction and reflection.
And it's way more advanced than just simple refinement. Agents use these internal evaluation loops. And they don't just repeat what worked. They learn from what was surprising.
Surprising.
Yeah. For instance, there are these Stanford-pioneered methods, like curious replay, where agents deliberately learn from peculiar or interesting experiences, tasks that were really hard to solve or that resulted in unexpected errors.
Okay, so what does that look like in practice? What does policy adaptation actually mean?
Think of it like a cycle. The agent generates an output, then it runs a reflection step where it critiques that output against its goals, and then it refines its plan for next time. Policy adaptation is the result.
So if it fails...
Right. If an agent tries to use an inventory API and gets a 404 not found error, a plan failure, it detects that, logs the failure, and automatically pivots to a recovery strategy. Maybe it tries a secondary inventory system, or it alerts a human admin immediately. It makes the agents incredibly robust. They don't just halt, they autonomously find a path forward.
Now we're moving from the internal logic of the agent to how they operate in the real world. And this is where it gets really interesting. Interoperability. For these multi-agent systems to work, they have to communicate with the external world and with each other.
Seamlessly.
And the sources all emphasize it. That tool use interacting with existing APIs and systems.
Yeah.
That's the true power of the whole agentic system. And that power relies entirely on standardized protocols.
Exactly. I mean, if every agent needs a custom integration for every tool, we've learned absolutely nothing from the last 30 years of IT architecture.
Right.
So we've seen two essential, really non-negotiable protocols emerge in 2026 to solve this.
Okay, first up is the Model Context Protocol, or MCP. The sources call this the USB-C for AI.
It's a perfect analogy. MCP standardizes how agents connect to external systems. It's a universal, stateful interface between the agent's brain and the tools. So instead of the LLM having to learn 1,000 different API formats, it just talks to the MCP. And the MCP handles all the complexity of authentication, state management, data formatting.
It just abstracts away all the messiness of the enterprise data layer.
Yeah.
And what's the practical business result of that?
Huge efficiency gains. The organizations implementing MCP are reporting 40 to 60% faster agent deployment times.
Wow.
You just eliminate that massive bottleneck of writing custom integration code for every single new task. This is the difference between deploying one agent in 6 months and deploying 6 agents in 1 month.
That's how you scale. Okay, the second critical protocol handles communication between agents, which is essential for these multi-agent systems.
Yeah.
The agent-to-agent, or A2A protocol.
Right. A2A standardizes discovery, negotiation, and communication among agents that might belong to different departments or even different companies. And the way they advertise what they can do is through these standardized digital documents called agent cards.
Agent cards, like little digital resumes for AIs.
Precisely. They're hosted at a specific standardized web endpoint. The sources mentioned the common format is .wellknownagent.json. This creates this kind of decentralized marketplace.
Okay, give me an example.
Imagine your goal is book a flight for our CFO. A specialized travel agent needs to find a way to pay for it, so it discovers other available agents by checking their agent cards. It finds a payment agent from the finance team that offers secure transaction capabilities.
And A2A lets them negotiate the details of that transaction and share the context to get it done, all without a human in the middle. That is true cross-functional automation.
It is, and it relies on that standardization. But before we get fully into governance, let's just circle back to memory for a second. We talked about vector databases, but memory is hierarchical. Where do these different layers of context actually live?
Right, we need to define those 3 layers clearly.
Okay, so the fastest and most immediate is short-term memory. That's just the model's context window, the immediate dialogue, the status of the current task. Then you have the massive, enduring long-term memory in the vector databases, holding all that organizational domain knowledge.
And the third layer?
That's episodic memory. And it's different from long-term memory. It's not general knowledge. Episodic memory is the historical log of specific past interactions, recalling the strategy that worked or failed in a previous instance. It's the operational history that feeds that self-correction loop we discuss.
Okay, so given the power these agents have to interact with real systems, we absolutely have to talk about the mandatory guardrails.
We have to.
What stops an agent from having a reasoning failure and taking some disastrous action?
This is why the sources insist on a multi-level guardrail stack. It's a defense in-depth approach. You start at the high level with prompt-level guardrails. These are hard constraints embedded in the system prompt, like do not provide legal advice under any circumstances.
But those can sometimes be, engineered around. Where's the hard deterministic control?
That's where action-level guardrails come in. These are deterministic measures, often outside the LLM itself. They might include whitelisting allowed APIs. So the agent literally cannot call an API that's not on the approved list-setting budget caps, or implementing a mandatory human-in-the-loop approval gate for high-stakes actions.
Like a big financial transfer.
Exactly. The agent does 99% of the work, but a human has to click confirm for that final 1%.
Let's shift gears to the payoff. We've covered the architecture, the safety systems. Now let's focus on the actual business outcomes. The source material had some very specific, quantified success metrics that show the ROI here is, well, it's no longer theoretical.
No, the impact is becoming really clear across multiple verticals. In customer support, for instance, agents are hitting a 70 to 90% containment rate.
And that means end-to-end resolution without a human handoff.
That's right. It's incredible efficiency. And in sales, autonomous lead qualification, personalized follow-ups, that's being linked to a verifiable 22% increase in overall conversion rates. The agents just make sure no lead falls through the cracks.
And the finance department is seeing staggering returns.
Staggering. Automated auditing, fraud detection. Those workflows are yielding a 210% ROI with a payback period of less than 6 months. I mean, that kind of financial return is why we're seeing such intense investment right now.
And it's not just the hard numbers. There's also customer perception.
Right. High-performing telecom agents were found to boost customer satisfaction by 10 NPS points. The speed and accuracy of the agent often results in a much smoother user experience.
But despite this huge ROI, we have to talk about the implementation reality the sources exposed.
Yes. Despite the massive potential, only 34% of organizations that have invested heavily have actually achieved what the sources call a full-scaled implementation.
And the biggest challenge isn't the model's intelligence or even the cost of compute. It's the sheer messiness of the existing corporate environment.
It's unstructured data quality issues. A proof of concept might work great in a clean lab environment, but then it fails when it's exposed to real-world workflows, legacy systems, and just poorly formatted data.
So that complexity demands a more sophisticated way to evaluate success.
Yeah.
You can't just measure accuracy when the system is operating in a loop across different systems.
No, you have to measure across multiple dimensions. The core evaluation framework has 3 categories. First is goal fulfillment, which is measured by things like containment rate and completion rate. Did the agent actually finish the job?
Okay, and the second?
User and business satisfaction. So that's your NPS and CET scores, but also internal metrics for the human teams the agents support. And the third is technical performance latency. Cost per successful task, token efficiency. If the agent gets the job done, but it costs 10 times what it should, that's not a success.
And surrounding all of this, holding it all together, is the regulatory landscape, specifically the EU AI Act.
This is the global benchmark. It's the legal framework that's driving compliance everywhere, even outside of Europe. The Act uses a mandatory risk-based approach. Unacceptable risk is things like social scoring, just flat out forbidden. Limited risk applies to systems like general chatbots.
And the most challenging tier for enterprise.
High risk. This category covers AI used in critical infrastructure, employment, HR management, law enforcement. Any enterprise using a financial auditing agent or an autonomous hiring system falls right into this category.
And that comes with a lot of requirements.
It does. Mandatory registration, strict data governance, human oversight mechanisms, those action-level guardrails we talked about, and really stringent documentation. Organizations have to be compliant, and the rules largely apply from August 2, 2026. That deadline is forcing everyone to get their governance strategy finalized right now. If we connect all this technical detail to the bigger picture, the strategic impact is really the emergence of a truly AI-native architecture. Systems are becoming intent-driven.
Intent-driven.
Yeah, so instead of clicking through screens and filling out forms, a user just expresses a complex goal, like prepare a trip to the customer with the most late potential in Q4, and the agent autonomously orchestrates that whole multi-step action across CRMs, travel tools, and scheduling systems.
It sounds like the operating system itself is becoming intelligent.
It is. We are moving toward what are being called agent operating systems, where the integration of memory, planning, and behavior is managed at a foundational level. And looking even further ahead, the sources discuss this fascinating concept of agent economies, where autonomous agents can actually transact with one another, using micropayments or internal digital currencies to prioritize resources.
So what does this all mean for you as a leader or learner today?
The critical challenge is really navigating that transition from, let's call it the speculative promise of agentic AI, to actual utility in a governed, scalable way.
Right.
And based on everything we've read, that means focusing immediately on 3 strategic pillars: governance, so guardrails and EU AI Act compliance; modularity, multi-agent systems; and interoperability protocols like MCP and A2A.
The technical execution is becoming easier every day. Strategic leadership, that's the new bottleneck. You have to know what you're allowing your agents to do. And that leads us to our final provocative thought for you to mull over. The source material suggests that organizations are moving towards specialized agents that take on formal roles in org charts, literally becoming AI employees. Now, if agents can learn from their own peculiar experiences and continually refine their own policies, essentially judging and correcting their own behavior, what strategic oversight role will human leadership need to take in an organization that's populated by self-evolving, autonomous digital workers? That's the question that really dictates success in the coming years.